Hi, you're welcome to this video on electron structure and the periodic table, where we'll be looking at the way electrons are arranged in shells and how this arrangement affects their position on the periodic table. So in the atom, the protons and neutrons are found in the nucleus, while the electrons are found outside in what's called the energy levels or shells. So how are these electrons arranged in the shells? Before we answer the question though, just know that the shells that are closest to the nucleus have lower energy than the ones further away from the nucleus that have high energy. So when filling it with electrons, the lower energy levels are filled first, and then the higher energy levels. A few things to note when filling electrons in shells is that the first shell takes a maximum of 2 electrons, and then the second and third shell takes a maximum of 8 electrons, whilst the fourth shell can take up to 18 electrons. Let's look at the element hydrogen. Hydrogen has an atomic number of 1, which means it has 1 proton and 1 electron because it's neutral. That 1 electron goes in the first shell like this. Sometimes you're asked to write the electron structure, not draw it like this. So in that case, you have to put the number 1 down representing the electron and then put it in brackets like this. For lithium, it has an atomic number of 3, which means it has 3 protons and 3 electrons. If you put the protons in the nucleus, and then the first 2 electrons go in the first shell, and remember the first shell can take a maximum of 2 electrons, that means the last electron goes in the outside shell. And you can write that electron structure down as the numbers 2 and 1, where each number represents the number of electrons in each shell. And don't forget the brackets. Let's look at 2 more examples. For sodium, it has an atomic number of 11, which means 11 protons and 11 electrons. Putting the protons in the nucleus, the first 2 electrons go in the first shell, and the next 8 go in the second shell. Remember, the second shell can take a maximum of 8. That leaves us with just 1 more electron that has to go in the outside shell. And you can write that down as 2, 8, 1 in brackets, which is 2 in the first shell, 8 in the second shell, and 1 in the outside shell. And finally, calcium, which has an atomic number of 20, has 20 protons and 20 electrons. So the first 2 electrons go in the first shell. The next shell takes up to 8 electrons. And remember, it can take a maximum of 8. And then the third shell can now take another 8. And then the final shell takes the 2 that's left, which means we can put it down as 2 electrons, 8 electrons, another 8 electrons, and then the final 2. Knowing the electron structure is really important because it helps to tell you where an atom can be found in a periodic table. If you look on the periodic table, the vertical columns are called groups and the horizontal rows are called periods, like group 1 and group 2, or period 1 and period 2. If you look closely, you see that lithium and sodium both have 1 electron in the outer shell, and they both happen to be in group 1. Beryllium and magnesium both have 2 electrons in the outer shell, and they are both in group 2. And I hope you see the trend built in here. And similarly, oxygen and sulfur both have 6 electrons in the outer shell, and they're both in group 6. So the point is, the number of electrons in the outer shell tells you the group number, and you have to know this. Also, if you look at lithium here, it has 2 shells, 2 electrons in the first shell and 1 electron in the outside shell, and it happens to be in period 2. So 2 shells, period 2. Look at magnesium here. It has 3 shells, 2 in the first shell, 8 electrons in the second shell, and 2 in the outside shell, and it happens to be in period 3. So this means that the number of shells tells you the period number. In summary then, the number of electrons in the outer shell tells you the group the atom is in, and the number of shells tells you the period. Thank you very much for watching, and I'll see you later.